Okay, review for final exam, unit 6. Number 4, find the length of a rectangle. The length of a rectangle is 20 meters and the width is 15 meters. Find the ratio of the width to the length of the rectangle. Okay, so the ratio of the width to the length. So make sure you write the number for width first. Number 4, width to length is going to be 15 to 20. And let's simplify all the way. So I'm going to divide both numbers by 5 to get 3 to 4. So the ratio is 3 to 4. Okay, make sure you simplify. For number 5, the measures of the angles in triangle UVW are in the extended ratio 1 to 1 to 2. Find the measures of the angles. So what that is telling you is that if you have a triangle and the ratio is 1 to 1 to 1, then if one of them's x, well actually two of them are x, then the third one would be 2x. So 1x, 1x, 2x. And according to the triangle sum theorem, all three angles need to add up to 180 degrees. So x plus 2x is 180. So 4x is 180. Divide by 4, so x is 45. So that means that the angles are 45 degrees, 45 degrees, and the one that's 2x is going to be 90 degrees. And then for number 6, find the geometric mean of 6 and 12. So remember, for geometric mean, you multiply both numbers and then find the square root. Okay, so 8 times 12, that is 96. Okay, and then the square root of that number. Okay, so 96 does not have a perfect square root. So you're looking for a perfect number that divides 96. And perfect number that divides 96 is going to be 16. Okay, so you could have the square root of 16 times the square root of 6, which is 4 square root of 6. Okay, so make sure you simplify it. All right, next, use the diagram and the given information to find the unknown length. So you're given this equation here. You need to find RP. So let's go ahead and substitute the values in. So I'm going to use this equation here. Rn is 4. Rp, we don't know what that is. I'll just put an X there. Or, yeah, I'll just put an X. So we know that X is Rp. Qm is 6. And QL is 10. So now that we have this equation, we cross multiply and solve for X. So 6x is equal to 40. We cross multiplied. And then divide both sides by 6 to get 40 over 6, which simplifies to 20 over 3. Okay. And that is RP. Okay. For number 8, again, we have this equation here. CD, that's that one we don't know, so that would be X. DB is 5. CE is 10. And then EA is 4. All right, so cross multiply, you get 4x is equal to 50. And then divide by 4. So x is 50 over 4, which simplifies to 25 over 2. And that is CD. And exercises 9 and 10 determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor. All right. So remember, polygons are similar if corresponding sides have the same ratio. Okay. So, for example, the 6 corresponds with the, the 8 corresponds with the 6, and the 12 corresponds with the 9. Let's see if it's the same ratio. So does 8 over 6, is that equal to 12 over 9? It's 8 over 6 equal to 12 over 9. So let's simplify for both fractions. 8 over 6, you could divide top and bottom by 2 to get a 4 over 3. 12 over 9, you could divide top and bottom by 3 to get a 4 over 3. Okay, so we have the same ratio. Okay, so this is actually also the scale factor. Once you simplify the ratio, that's the scale factor. Okay, that's this part. We still need to write a similarity statement. Okay, so let me show you what that looks like. So now we have to state that the polygons are similar. So this is a quadrilateral. So polygon ABCD is similar to, use just a single squiggly line, and that's similar to EFGH. Okay. So this right here is the similarity statement. All right, for number 10, we have a triangle. So we have to verify that the 3 sides of the triangle have a common ratio, which is the scale factor. Okay, so let's start with the shortest part, then the middle part, and then the longest part. Okay. So the shortest part of the triangle is the 15. So we're gonna compare it to the 6. And we want to see if that's equal to the 20, the middle one, which is corresponds to 8. And we want to see if the 25 corresponds with the 10. So these 3 fractions have to be equal. So let's simplify them. 15 over 6, you could divide the top and bottom by 3 to get 5 over 2. 20 over 8, you could divide by 4 to get 5 over 2. And then 25 over 10, you could divide by 5 to get 5 over 2. Okay, so these fractions are the same. This is the scale factor. And now we have to give this similarity statement. So triangle X, Y, Z is similar to triangle PQR. Make sure the letters correspond as well. Okay, so scale factor and similarity statement. Okay, next part. Use the angle-angle similarity postulate to show that the triangles are similar. Okay, So for this part, as long as we could show that two corresponding angles are similar, then automatically the triangles are similar. Okay. So here, one of them is given. Um, Angle Q is congruent to angle T. That's given. And then here in the middle, these two angles are related. They're congruent as well because they're vertical angles. Angle RSQ is congruent to angle TSU because they're vertical angles. Okay. So I just showed you that two pairs of corresponding angles are congruent, so that means the triangles are congruent. So now I could write the similarity statement. Triangle QRS is similar to triangle TSU because of the angle-angle similarity postulate. Okay. For number 13, let's see, C and F are both right angles. So angle C is congruent to angle F because they are right angles. Okay. And if they're right angles, they have to be congruent. Okay. And then I could say that angle B is 30 degrees because of the triangle sum theorem, right? It has to be 30 because you have 60, the right angle is 90, that's 150. So angle B has to be 30 because all three of them have to add up to 180. So that means that angle B is congruent to angle E because of the triangle sum theorem. So that means that the triangles are similar. So triangle ABC is similar to triangle DEF because of the angle-angle similarity postulate. Okay. All right, for this one, we're going to use the side and side angle side similarity postulate theorem to show that the triangles are similar. Okay, so let's see here. Okay. So for number 15, I'm going to use side angle side. Okay. It might be easier to separate the triangles. So I'm going to redraw the big triangle down here. Okay, the big triangle is triangle CAE. Okay, and from A to C, it's actually 12, the 8 plus the 4. And from C to E, it's actually 10.5. Okay, 3.5 plus 7 is 10.5. Okay, so I'm comparing this small triangle here and then the big triangle. Those are the two triangles that I'm showing, that I'm going to show that are similar. Okay, so first, so let's compare the sides, the two sides. Okay, side angle side. So let's compare the 4 to the 12 and then the 3.5 to the 10.5. We have to check if these are equal, okay? 4 over 12, I could divide the top and bottom by 4 to get 1 over 3. And then 3.5 over 10.5, I could divide the top and bottom by 3.5 to get 1 over 3 as well, okay? So the sides correspond, okay? So I have two sides, um, two pairs of sides that correspond. I just need the angle part. So the angle that they share is angle C, right? Both triangles have angle C. So angle C is congruent to angle C. That's because of the reflexive property. That's the reflexive property of congruency. Okay, so that gives, so now I have side, angle, side. So the triangles are similar by side, angle, side. Okay. So therefore, triangle CBD is similar to triangle CAE by the side, angle, side similarity theorem. Okay. Last one, 15. I mean 16. Um, Again, I'm gonna draw the big triangle. I'm gonna draw it over. So this is 15. The bottom is 21. 7 plus 14 is 21. And over here, 4.5 plus 9 is 13.5. Okay, so I'm comparing the big triangle to this triangle here. And I'm going to prove that they're similar by side, side, side. So that means that all three corresponding side lanes have to be equal to each other. So I'm going to compare the 10 to the 15, the 9 to the 13.5, and the 14 to the 21. All right. Now I'm going to simplify these fractions here. 10 over 15, I could divide top and bottom by 5 to get 2 over 3. 14 over 21, I could divide top and bottom by 7 to get 2 over 7. And 9 over 13.5, you could actually divide by, I'm sorry, that should have been 2 over 3. 14 over 21 is 2 over 3. And then 9 over 13.5, you could divide by 4.5. 4.5 goes into 9 two times, and 4.5 goes into 13.5 three times. Okay, so look at that. All three sides correspond, so you have side, side, side. Okay. So triangle RUQ is similar to triangle RTQ. I'm sorry, STQ, because of the side, side, side similarity theorem.